So there are a lot of elimination problems here. As I talk through them, I'm going to speak fairly quickly. If you need to rewind, please do so. And if you need to pause to look at something, please make sure you can do that as well. When I do the elimination method, what I want to do, I want to combine these two equations together to add them together so that I eliminate or get rid of one of my variables. Now in this case, if I add these together as they are, 3x plus a negative 2x is 1x, negative 4y plus 3y is a negative 1y, I don't eliminate a variable. So I look and I say, well, 3 and 2 both go into 6, or 4 and 3 both go into 12. I'm going to deal with the smaller numbers. I'm going to say if I multiply the first equation by 2, this becomes a positive 6x. And if I multiply the second equation by 3, this becomes a negative 6x. Then when I add a positive 6x to a negative 6x, the x's are eliminated. Now, what this is going to give me when I multiply this whole first equation by 2 is 6x minus 8y equals negative 4. Don't forget to multiply both sides by 2. The second equation becomes negative 6x plus 9y equals positive 3. Now again, when I combine these equations, 6x and a negative 6x is 0, negative 8y and positive 9y is just a 1y, and negative 4 and positive 3 is negative 1. In this case, I didn't have to do anything else to solve for y. Now it's already by itself. Now that I know y is negative 1, I take one of my two original first equations, so 3x minus 4y equals negative 2, doesn't matter which equation. Y is negative 1, so 3x minus 4 times negative 1 is negative 2. Simplifying 3x. I can treat this as negative 4 times negative 1 to get a positive 4, or if I wanted to bring the minus down as a minus, then 4 times negative 1 is negative 4, and it would be minus a negative 4 instead, which is the same thing as plus 4, equals my negative 2. Now, I'm going to subtract 4 from both sides to solve this two-step equation. 3x equals negative 6. Then when I divide by 3, x equals negative 2. My final answer is the ordered pair negative 2, negative 1. If I graph those two lines, that's where they intersect. In this equation, again, I don't have opposites to begin with. 8 doesn't go into 11, 2 doesn't go into 3. I'm going to choose to deal with the smaller of the set of numbers, the 2 and the 3. 2 and 3 both go into 6. So if I multiply the first equation by 3, it'll make this a positive 6y. And by negative 2 here, we'll make this a negative 6y. So multiplying everything in the first equation by 3, 33x plus 6y equals negative 24. Multiplying everything in the second equation by negative 2, negative 16x minus 6y equals negative 10. Combining my two equations, this becomes 17x equals negative 34. Divide both sides by 17, and x equals negative 2. Now, it looks to me like the second equation might be easier to work with than the first one. It doesn't matter. So 8x plus 3y equals 5. I can almost read that. But now I know that x is negative 2. So 8 times negative 2 plus 3y equals 5. 8 times negative 2 is negative 16. Bring down my plus 3y equals 5. When I add 16 to both sides now, I end up with 3y equals 21. And then when I divide by 3, I get y equals 7. So if I graphed these two lines, they would intersect at the point negative 2, 7. Don't forget to write your answer as an ordered pair. Now this third one is nice because negative 4x and positive 4x, those are already opposites, so I don't have to do any multiplying. I can just combine to get a positive 6y equals a negative 36, and then when I divide both sides by 6, I get y equals negative 6. To me, it looks like the first equation is easier to work with, so negative 4x minus 2 times y is negative 6 is negative 12. Negative 4x, negative 2 times negative 6 is a positive 12. Now, when I subtract 12 from both sides of the equation, I get negative 4x equals negative 24, And then when I divide by negative 4, to isolate the variable, I get x equals 6. So if I graphed these two, they intersect where x is positive 6 and y is negative 6. In this one, they are not opposites yet. These are both negative 6x. But if I multiply everything in the first equation by negative 1, it'll make it a positive 6x. And then a minus 6y equals a negative 6. Again, multiply everything by negative 1. When I combine these two equations now, I'm going to get negative 3y equals negative 18. And then when I divide by negative 3, I'm going to get y is 6. So I know my answer is going to have an ordered pair where y is 6. Now I just need to go find x. Again, the first equation looks maybe easier to work with. So negative 6x plus 6 times y is 6. Oops. So I'm going to put a 6 in for my y equals 6. Simplifying this down, negative 6x plus 36 equals 6. When I subtract the 36 from both sides to move the constant to the right, I get negative 6x equals negative 30. And then when I divide both sides by negative 6, I get x equals positive 5. So it's the 0.56 that I was looking for. And the last one, I don't have opposites, but I do notice that 7 goes into 14. So I can multiply the second equation by 2. The first one's already a plus 14y. So then when I multiply everything here by 2, it becomes negative 12x minus 14y equals negative 20. Now my first equation is going to stay the same, 8x plus 14y equals 4. Now when I combine these, I get negative 4x equals negative 16. Then when I divide by negative 4, I get x equals positive 4. And I have to go find y. So taking my first equation, 8 times x is 4 plus 14y equals 4, which becomes 32 plus 14y equals 4. Now when I subtract 32 from both sides of the equation, I get 14y equals negative 28. Dividing by 14 gives me y equals negative 2. So my point is the point 4, negative 2. That's part 1 of the elimination method.